Hi, this is Mr. Ward, and I'm going to do a video key for exit ticket 28.3 for us, week 28, day 3, and here we go. And this is stuff from Quadratics 2. We're going to multiply out, or expand, y equals x plus 3 times x plus 3. And of course, you have many options for how you can make sure you get all four combinations, but you do need to get all four combinations. So I'm going to just put it up here. So I've got x and 3 added together, and x and 3 added together. This is just going to be one of the methods. This is called the box or grid method. And what I'm going to do is I'm going to work out, I have like 4 spots for my products here. Okay, so since I didn't put a sign in between here, assume it's plus. Okay, if it was a -3, it would be minus. This is also plus, okay? So x times x goes here. So x times x is x squared, because when you multiply something times itself, it is just squared. And then here is going to be 3 times x, so that's just 3x. Up here is going to be 3 times x as well, which is going to be interesting for our results. And then 3 times 3 here, which is going to be 9. And so now I have all my parts. The 3x and the 3x are like terms, so I'll be able to add them together. Okay, and they're just going to be doubled. So I've got x squared in the beginning. I've got a 9 in the end. I've got a 3x and a 3x. And since none of them are negative, everything is just addition. So that's addition, and that's addition. Now, of course, you know that if we have two of the same thing being added together, we could relate to that as 2 times 3x, like that. That's the same thing as 3x. And so what we've got here, when we multiply this out, we got x squared at the beginning, we've got 3 squared at the end, and then we got x times 3 plus x times 3, or 2 times x times 3. And this, you notice these are the same factors. So this could have been written as x plus 3 squared if we had wanted. This is actually a special case. This is called a perfect square. So I've got x squared plus 6x plus 9 is the product that you get. Okay, and I'm just going to make a note here. If you have this structure, a plus b squared, which is the same as a plus b times a plus b, you've got a squared at the beginning, you've got my x squared there, you've got b squared at the end, but then we're going to be doing a times b and a times b again, so really you have 2 ab's in the middle. So this is a structure called a perfect square structure that will be useful to keep track of. You should actually write this down if you have not already done so. So a squared plus 2ab plus b squared is what you get when you have a plus b squared. If it was a minus b squared, then you'd have, of course, that's a minus b times a minus b, and then you would end up with a squared at the beginning. You'd still end up with b squared at the end, because negative b times negative b would be b squared. The negatives cancel out. But then you'd have a times negative b and negative b times a. So that's 2 negative ab's. So 2 ab, but that's negative. Okay, and then that'll be positive. So those are perfect square structures. I'm going to label this perfect square. And that's an extremely important structure that's going to be with you in various things going forward a long way. So perfect square is very important. Later on, we'll be doing a thing called completing the square. You're going to need to know how to recognize or change something so it can be that. Okay, if we do this one's a little different. Instead of x both being the same, I've got an x minus 3 and an x plus 3. these have a fancy name. These are conjugates of each other. If I have a plus b and a minus b, and I'm multiplying them together, that is, I'm multiplying two conjugates together. And when you do that, we have a situation where the outside and the inside products are going to cancel out. So I'll do this the distributive property way. So I'll copy this down here. So this is the horizontal distributive property. This is one of the many ways we can do this. So I've got x times x plus 3, and then I'm going to say minus 3 times x plus 3. And I'll distribute, first I'll distribute the, okay, then I'll distribute the x times x, which will be x squared. Then I'm going to do x times 3, so it'll be plus 3x. Then here I've got minus 3x, so minus 3 times x. And then minus 3 times 3, which will be minus 9, negative 9. And when I put all that together, you'll notice, hopefully, that this 3x and this negative 3x are going to cancel each other out. And you'll end up with, really in the middle, a 0x, which we don't actually need. We just end up with x squared minus 9. And this is a particular mathematical structure called a difference of squares. This is a special case. So when you have, this is x squared, and that's negative of 3 squared. So x squared minus 3 squared is what we have here. So if anytime you have something like a plus b times a minus b, so it's the product of the sum and then the product of the difference of the same things, you're going to end up with a squared plus, actually, I'll have to say I'll deal with this. So we a squared, and at the end you'll have a minus b squared. And in the middle, you're going to have I've got a negative ab and a positive ab. So I'll say negative ab and positive ab. And those two things are just going to cancel each other out. And so when I copy and I bring this over here, I'm just going to end up with a squared plus 0ab plus b squared, which is really, I'm sorry, minus, what am I saying? That's minus. It's a copying error, Mr. Word. It's a jumbo mistake. So now we've just got a squared minus b squared. Okay, and that is a square, and that's a square, and it's a difference of two squares, so we call it a difference of squares. This is another structure that will be really handy to pay attention to going forward into the future. I hope that helped.